So in the last couple of videos, we talked about a bunch of interesting stuff, light pollution. We discussed how light is this wonderful messenger for astronomers. Like if you're an astronomer on Earth here looking into your telescope, you can study things by collecting their light, maybe the light that goes from the sun, hits the moon, then reflects into your telescope, or maybe there'll be some light from the sun that reflects off of Venus and goes in your telescope. Because remember, moons and planets don't generate their own light. We see them from light reflected from the sun. We can see them and learn a lot about them by that reflected light. And of course, we don't forget that stars do make their own light. So a very distant star, or maybe there's like a little galaxy up here. Some of its light can also stream across the cosmos into our telescope, and we can study that too. So like I said, light is the great messenger in astronomy. Oh, and I just want to make sure I draw the sun properly here. You're supposed to put a face on the sun. There we go. Yeah, good. Okay, I've got the sun all tweaked up. Right? Okay. So what I want to tell you about in this video here is, okay, what is light then? This great messenger and this fantastic thing that allows astronomers to do all these things. What is it? Okay. So what it is quite complicated to describe. Light may be also the great messenger, but underneath it all, what light actually is a great mystery as well. We have a very strong mathematical framework and theoretical framework for what it is and how it behaves, but the deeper you look, the weirder it gets, even now. And so I'm going to give you just some facts about light that are relevant for astronomy. Okay, how about that? So the first thing that we need to know about light here is that it basically travels, no matter where it is or what it's doing, in straight lines. Okay, it always travels in straight lines. And the second thing is it always has this fixed speed of 186,000 miles per hour. Miles per hour? No. Miles per second. Okay, so it's one of the earliest numbers I remember sort of learning. As a young kid, because I knew what 55 miles per hour was, but suddenly light comes in 186,000, not miles per hour, miles per second. So not only is 186,000 much bigger than the 55, but it's not even miles per hour, it's miles per second. So light's pretty fast. The other number in the metric system is 300 million meters per second. So if you hold your arms, about a meter or so, which is 3 feet, many of you, I know a good portion of your height probably, light would travel across that distance in about a second. So light will travel from about, I don't know how tall you are, maybe your neck or your waist down to your feet in about a second, okay? And the other thing you can kind of do in front of you here is actually travels 1 foot every nanosecond. So what that means, of course, is if you had a flashlight or something like this, so here's a flashlight here that maybe you turn on, or maybe the light on your phone or something like that. If you sort of held your hands 1 foot apart, so if you hold sort of like, 1, 2, 3, well, I wanted to use a skin tone here. I don't know how I lost that. Here we go, something like this. So here's your hand, maybe here's your thumb. 1, 2, 3, 4. There's a hand, and here's another thumb over here. 1, 2, 3, 4. Okay. If you held your hands like 1 foot apart, like do this right in front of you as you're watching, just hold your hands 1 foot apart. If a beam of light was coming from a flashlight or a torch on your phone or something like that, and started at one hand and went to the other one, when you're holding it 1 foot apart, it would take about 1 nanosecond to traverse your hands. So anyway, sort of definition of a nanosecond, which is another kind of a strange number here. Nanosecond means billionth. So 1 billionth of a second is how long light from a flashlight would take to cross your hands if you held it 1 foot. So light's pretty fast, okay? The third thing about light here is it comes in 2 forms, both of which we can sort of use when we talk about things that happen in astronomy. The first form that it comes in is a photon. And what photons are little dots like this. You can definitely think of photons as little balls of light. So if you want to think of it like a baseball or a ping pong ball or something small like that, if you just think of that ball as pure energy traveling around in straight lines at 186,000 miles per second, or 1 foot every nanosecond, something like that, well, by golly, that's exactly what a photon is. So they'll just be humming along here, at 186 1,000 miles per second through the cosmos, for sure. That's what a photon would be, okay, little balls of light. The other form that light takes on, what did I call that, number 3? Okay, maybe we'll call this, that is fact a photon, we'll call it 3A. And 3B over here is light can also be categorized as a wave or waves. And this is the one that we'll probably use the most here coming up for a while to describe some astronomy, but I'd like to tell you what that is. Waves always confuse people, but the way you would draw light in this form here wouldn't be like little balls of light like this. You wouldn't do that anymore. That's the photon view. Light is a photon. That's when it's a little ball of light. But if you're going to draw it like a wave like that, you would literally make yourself a little coordinate system like this to orient yourself if you'd like. And then you'd come in and go, okay, the light is going to go up and down and up and down and up and down like that. And this is what light would do. This would be light as a wave. It'd be a wave like this, up and down and up and down. So what I need to tell you about now with waves are 2 things. We need to discuss the frequency of a wave and the wavelength. These are the most important things that characterize waves. And it turns out when we're done with, well, the confusion that I'll get to in the next video here, we'll see that we'll just sort of stick with wavelength because that's what's going to help us the most to understand some astronomy. Okay, next video, frequency and wavelength.